In this video, we're going to talk about how to rationalize a denominator using radical conjugates. So remember, we talked about multiplying binomial radicals, and remember we said we can use the difference of squares to multiply binomial radicals that are conjugates. So remember, a conjugate will have that form that's like a plus b times a minus b, and that's why we can use a squared minus b squared to multiply those two together. So notice that when you multiply binomial radicals, there won't be any radicals in the product. That's why we can use conjugates to rationalize the denominator. Because remember, when we talked about rationalizing the denominator in the previous video, we said that the goal is to have no radicals in the denominator. So let's look at this example. So we want to simplify this expression, 5 over 2 minus the square root of 6. And so to do that, we want to make sure that there's no radicals in the denominator. So we're going to look at 2 minus square root of 6 and figure out the conjugate. The conjugate is going to happen when we switch that sign, so it's going to be 2 plus the square root of 6. Remember that we are allowed to multiply any expression by some form of 1 over 1. So we can take this original fraction and multiply by 2 plus the square root of 6 over 2 plus the square root of 6. So when we do that, that 5 is going to distribute to both of these terms, so we get 10 plus 5 square root of 6. And then in the denominator, we can use the difference of squares. So the denominator is going to basically be 2 squared minus the square root of 6 squared. Well, 2 squared is 4, and then the square root of 6 squared is just 6, so 4 minus 6 is how we get that negative 2. So notice that this expression is fully simplified because now we have no radicals in the denominator. So here's how we use conjugates to rationalize the denominator. You'll start off by determining the conjugate of the denominator. Then turn the conjugate into a form of 1 over 1 and multiply by the original expression. Then we multiply the fractions, remembering to use the distributive property and the difference of squares whenever needed. Then we simplify whenever possible. So let's start off with this example. So notice that this is not simplified because we have a radical in the denominator. So I'm going to start off by figuring out the conjugate. The conjugate of 3 plus the square root of 2 is going to be 3 minus the square root of 2. So I'm going to take this 5 over 3 plus the square root of 2 and multiply by 3 minus the square root of 2 over 3 minus the square root of 2. So when I do that in the numerator, this is going to turn into 5 times 3 minus the square root of 2. I have to put that in parentheses because that 5 is going to distribute to both of these terms. In the denominator, I have 3 plus the square root of 2 times 3 minus the square root of 2. Okay, so now let's simplify this. When I multiply both terms in the numerator by 5, I get 5 times 3, so that's 15, minus 5 times the square root of 2, so that's just 5 square root of 2. So in the denominator, I can use that shortcut because remember this is like a plus b times a minus b. So I'm going to use the difference of squares, so I have 3 squared minus the square root of 2 squared. So in the numerator, I just have to leave that 15 minus 5 square root of 2 like that because those are unlike terms. And then in the denominator, well, let's see, 3 squared is 9, and square root of 2 squared is 2, so we have 9 minus 2. So this is going to simplify to 15 minus 5 square root of 2 over 7. And that's the simplified form of this expression. So now you can go ahead and pause the video and try doing this example on your own. So here we have 2 plus the square root of 3 in our denominator, so the conjugate is going to be 2 minus the square root of 3. So we're going to multiply this fraction by 2 minus square root of 3 over 2 minus square root of 3. In the numerator, we're going to distribute the 6, which gives us 12 minus 6 square root of 3. And then in the denominator, we use the difference of squares, so we have 2 squared minus the square root of 3 squared. So in the numerator, we have 12 minus 6 square root of 3. And then in the denominator, we have 4 minus 3, which is equal to 1. So that's just going to simplify to 12 minus 6 square root of 3, because remember, we don't need to write that over 1 when that's in the denominator. So now let's try simplifying this expression. So we have a radical in the numerator and the denominator, but it doesn't matter if we have radicals in the numerator, right? We just want to get them out of the denominator. So we're only going to look at the conjugate of the denominator. So that's going to be 4 minus the square root of 3. So I'm going to take this 6 minus square root of 3 over 4 plus the square root of 3, and I'm going to multiply by 4 minus the square root of 3 over 4 minus the square root of 3. Okay, so in the numerator, this is going to turn into 6 minus square root of 3 times 4 minus the square root of 3 over 4 plus the square root of 3 times 4 minus the square root of 3. Okay, so since we have two binomials in the numerator, we actually have to use FOIL. Okay, so let me write out all the terms. So we do first times first, so that's going to be 6 times 4. And then we have our outside terms, so we have minus 6 times the square root of 3. And then we have our inside terms, so we have minus 4 times the square root of 3. And then we have our last terms, well, we have a negative times a negative, so that's going to become positive. And then we have the square root of 3 times itself, so I'm just going to write that as the square root of 3 squared. And that's going to be over the denominator. Well, there I can use the difference of squares because I'm multiplying conjugates. So this is going to be 4 squared minus the square root of 3 squared. Okay, so now let's simplify, try to collect like terms and do all of that. So we have 6 times 4, which is 24, minus 6 square root of 3 minus 4 square root of 3, and then plus the square root of 3 squared, well, that's just going to be plus 3. And that's over, let's see, 4 squared is 16, minus square root of 3 squared, well, that's just going to be 3. Okay, so now I'm going to rearrange the numerator so you can see my like terms. Notice that I have a 24 and a 3 that I can put together, so I have 24 plus 3, and then minus 6 square root of 3 and minus 4 square root of 3 are also like terms. And that's going to be over 16 minus 3, which is 13. So now when we simplify this, 24 plus 3 is going to become 27. Minus 6 square root of 3 minus 4 square root of 3 is going to become minus 10 square root of 3. And that's all going to be over 13. So that's the fully simplified form of this expression. So now you can go ahead and pause the video and try doing this example on your own. So here in the denominator, we have 6 plus the square root of 3. So the conjugate is going to be 6 minus the square root of 3. So we're going to multiply the numerator and denominator by 6 minus square root of 3. So in the numerator, we need to FOIL. So here's my first, and then here's outside, inside, and last. So the first term is 54, and then my outside and inside, notice that they're like terms, so I can go ahead and combine them. So minus 9 square root of 3 minus 12 square root of 3 is minus 21 square root of 3. And then 2 times the square root of 3 squared, well, that's just 2 times 3. So that's going to end up being 6, and that 6 can combine with 54, which is how I got that 60. So then we can combine the terms in our denominator, so because we have 6 squared minus the square root of 3 squared. So we have 36 minus 3, and that's going to give us 33. So I did an extra simplification step because notice that all of these terms are divisible by 3. So remember, when we're working with fractions, we can simplify if we have something that's divisible by everything. So we can, divide this by 3, and that becomes 20, divide this by 3, and that becomes 7, and divide by 3, and here we have 11. That's how I ended up with 20 minus 7 square root of 3 over 11. So whenever a radical expression involves a fraction, it needs to be simplified by rationalizing the denominator. When the denominator is a binomial radical, you can use the conjugate of the denominator to rationalize.